Okay, so hi everyone. So welcome back to the second video in this sliding window series of CSES problem set. So today in this video we are going to solve this problem that goes by the name sliding window XOR, right? So let us start with this problem now. So the problem reads like this, that you are given an array of n integers. So you will be given with n integers and your task is to calculate the bitwise XOR of each window of k elements from left to right. And in this problem the input data is large and it is created using a generator, right? So it is exactly similar to the previous problem. The only difference is that instead of calculating the sum for each window, now you have to calculate the XOR for each window, right? So this is the only difference. So let us read further. So in the input, the first line contains two integers n and k representing the number of elements and the size of the window, right? And then the next line contains four integers x, a, b, c, the input generator parameters, and the input is generated as follows. So this is the function given. So the value of the first element will be always equal to this x, and the value of the remaining elements can be generated using this function, which is called as generator function here, right? So after taking the input, you have to print the XOR of all window XORs, right? So after you have computed the XOR value for each window, you have to take the XOR of all those XORs, right? I hope you got this. So in the previous problem, it was written that we have to print the XOR of all window sums, but here it is written that we have to print the XOR of all window XORs, right? So this is the only difference, and the constraint is same, that is the value of k and n can go up till 1e7, the value of xab can go up till 1e9, and same for c. So this is the example given for which the expected output is 0, but since this example is not very large enough and good, so what I am doing here is I have considered example by myself. So let us try to understand this problem with that example, right? So this is the example that I have considered. So in this example I have assumed that this array should contain a total of 11 elements actually, right? That is from 1 to 11, right? So since I want to solve this problem using one based indexing only, so that's why I have made this array into a one based type. That is, I have considered this 0th element on the 0th index by myself, because our actual array only starts from the first index and goes till the value of n, which is 11 here. So 1 to 11 is our actual array, and this I have considered by myself, right? So suppose you are given this array and also you are given the value of k equal to 4, that is the window size is 4 here. So for each window of size 4 you have to compute the XOR. So once you have understood this array here, let us try to move forward and solve our problem for the very first window, right? But before moving to that, as I have told you before also, that for a fixed size window, if you want to calculate the total number of windows that will be present, so you can calculate it by n minus k plus 1 formula. So since here the value of n is 11 and k is 4, so 11 minus 4 plus 1, which is equal to 8. So a total of 8 windows will be present here. So keep this in mind. And even if I tell you here, so our very first window will go from 1 till this 4, right? So our first window will end at this. Similarly, our second window will end here, third, fourth, fifth, sixth, seventh, eighth. So that's why a total of 8 windows will be present, which you can calculate from this, right? So once this is clear, so since I have to print an integer at the end, so that's why what I'll be doing is every time I compute the XOR for each window, I will be XORing it with this variable, because at the end I have to print this result variable, right? So this is our ultimate result that we have to print, and initially it is equal to 0, because we know that if we XOR 0 with any variable, then it is equal to that variable. Similarly, if we XOR any variable with itself, then it is equal to 0. So let us move forward and try to see how we will deal with the first window. So this is our very first window, right? Because as I have told you that our actual array starts from the first index and goes till the 11th index, so that's why this is our very first window, which is starting from the first index and going till the 4th index, right? In order to calculate the XOR for the very first window, what we will do is we will simply calculate the XOR of this window by iterating from the first index till the 4th index. That is, we will run a for loop from 1 to 4. So that's why what it will do is it will simply calculate 3 XOR 5 XOR 1 XOR 3, which will be equal to 4, right? So in this way I can say that the window's current XOR is equal to this 4. So I will simply XOR the value of this current window XOR with this result variable, because every time the result, that is the current window XOR is calculated, I have to update it in this result variable, right? So that's why I will say for XOR this result variable here, which is 0. So 4 XOR 0, which is equal to 4 only. So I can say that after completing this very first window, right, after completing this very first window that we have computed manually by not using any previous result, I can say that our result variable is equal to 4, right? So in this way we will complete our very first window, and after completing this very first window we will move forward and try to solve our problem for the remaining windows one by one. So this is our second window, as you can see, right? So this is our second window. So earlier it was here, then we move one step ahead, so now it is here. So now we want to calculate the XOR of this window, that is 2, 3, 4 and 5, right? So how can we do this? So since earlier our XOR was this, that is 3 XOR 5 XOR 1 XOR 3, and it was for this window, right, that is from 1 to 4. But now our window has slided one step forward, so it is clearly visible that in this window and in this window, this 5, 1, 3 are the common elements. The only difference is that while moving from this window to this window, this fifth index element is getting added and this first index element is getting removed, right? So when we are moving from this window to this window, then this 7 is getting added and this 3 is getting left behind, right? So that's why I can say that when we want to compute the XOR for this window, then it should only comprise of 5 XOR 1 XOR 3 XOR 7. So how can we do this using this previous result? So since our previous result has 3 XOR 5 XOR 1 XOR 3, right? So write that result here. So 3 XOR 5 XOR 1 XOR 3. So if you take the XOR with this next element, that is this, that we have to add, that is we have to add the contribution of this 7, that is we want to take the XOR of this 7 with the remaining XOR value, right? So that's why, since this was our earlier XOR value, so now what I'm saying is to take the XOR with this, that is XOR 7, that is nums of 5, that is nums of next element. And if you took this, then also we have to remove the contribution of 3 which was present before, right? So it was pretty easier for us to include the contribution of this next element by simply taking the XOR. But how we will remove the contribution of this previous element? So in order to do this, as you already know that if you take the XOR, so let me write here, so if you take the XOR of 3 with 3 only, so what it would be equal to? So it would be equal to 0 only, right? Because the XOR of two integers is same. So that's why, since we want to remove the contribution of this 3, so what we will do is, so since as of now our current XOR is equal to this 3 XOR 5 XOR 1 XOR 3, which was the previous result, and then now we have added this XOR, I am telling you to take the XOR of this previous element again, that is XOR 3. So by doing this, what will happen is, these 3 that I have taken into account just now will cancel out with the one in which it was present in previous window, right? So since this 3 was present in previous window, so that's why this 3 was present here, and as I have slided the window forward, so this 3 is getting removed. So in order to cancel its effect, I am again taking a XOR with it. So if you take again a XOR with it, then this 3 and 3 will cancel out each other and will become equal to 0. It will be equal to then 0 XOR this 5137, so which would be equal to ultimately 5137 only, which is this, right? And the value of this 5 XOR 1 XOR 3 XOR 7, that is the XOR of this window, is nothing but 0, right? So this 0 is the XOR of this window, and since we know that we have to update our result variable every time by taking a XOR with it, so since the value of XOR of current window is 0, so I will take the XOR of this 0 with the previous result. So since the previous result was this 4 here, so I will take the result of this 4 with this 0, which will be equal to 4 only. So that's why I can say, after processing this second window, the value of my result variable here is 4, right? So I hope you got this, and now we will do the again same thing for each and every remaining windows, right? So that's why this will be our third window. So this was our first window, then we slided one step ahead, so this became our second window, and now this is our third window, right? So again for this window, we want the ultimate result of equal to 1 XOR 3 XOR 7 XOR 6. So how can we achieve this? So again we will do the same thing. So since for the previous window the XOR was equal to 5 XOR 1 XOR 3 XOR 7, right, which I have written here. So now since it has slided one step, so it means that it has added this new element and it has removed this element, right? So since you want to add the contribution of this element now, so that's why what you can do is you can take the XOR of this next element, that is nums of next element, that is 6. So XOR 6. So now the window is, as of now, it should look like this, right? If we just write this XOR 6. But if we again take the XOR with this nums of previous element, which is 5 here, so what it will do is it will simply cancel out this 5 with this 5, right? So this 5 is coming from the previous window and this 5 I have considered right now. So these two will cancel out each other and the result will be 1376, right? And after cancelling out, also this window will reduce to this, right? Sorry, this window here, it will reduce to this. And that's why you can see that the XOR of this window should be 1376, which is coming here also, right? After this, both of the 5s have been cut. And if you calculate this value, that is 1 XOR 3 XOR 7 XOR 6, then it will come equal to 3. So it means that the XOR of this current window is equal to 3. So what you have to do, you have to take the XOR of this current window with the previous result. And since the previous result was equal to 4, so I will write here 4 XOR 3, which is equal to 7. So I can confidently say now that after processing this third window, the result value is equal to 7. So there are 5 more remaining windows, right? So let us do them also quickly. So this is our fourth window. So in this we have to calculate the XOR of 3 XOR 7 XOR 6 XOR 1, that is from 4 to 7. And since earlier the window consisted of XORs of 1376, which I have written here. So now you know what you have to do. You have to take the XOR of nums of next element and also the XOR of previous element. Why? Because by taking the XOR with the next element, it will add its contribution, and by taking the XOR with the previous element, it will cancel its contribution, right? That is, since here both is 1, right? So that's why XOR 1 XOR 1. So this 1 will cancel out with this 1, that is the same element but coming in different windows, right? So the resulting value is this, that is 3761. And if you calculate this 3 XOR 7 XOR 6 XOR 1, which is nothing but the elements of the current window, so it will be equal to 3. So I can say that the XOR of this current window is equal to 3, and what we have to do, you have to take the XOR with the result variable, because at the end we have to print that result variable only. So I can say this 3 XOR this 7. So 3 XOR 7, which is equal to 4. So that's why I can say that after processing this fourth window, my result value is equal to 4. In this, our fourth window is also completed. Let us move forward to the fifth window, right? So this is our fifth window, and in this we want to calculate the XOR from the 5th index till the 8th index, right? And in order to do this, since in the earlier window it only consisted of 3, 7, 6 and 1, right? Which is, I have written here 3 XOR 7 XOR 6 XOR 1. And what we will do, we will add the contribution of this next element by taking a XOR with it, and we will remove the contribution of this previous element by taking a XOR with it, right? So by taking XOR 8, it will take its contribution, and by taking XOR 3, it will cancel out with this. So both these elements are of the same index but are coming from the different window. So this is from the previous window, this is from the next window. So after both of this has been cancelled, this will remain, that is 7618. And if you see here, this 7618 is present here exactly, right? And we are taking its XOR only. So if you calculate, then its XOR will be equal to 8. So it means that the XOR of this current window is equal to 8, which has come here. And now what we have to do, we have to take the XOR of this current XOR, that is 8, with the previous result. And since our previous result was equal to 4, so I will say 4 XOR this 8, which is equal to 12. So that's why I can say that after processing the fifth window, our result is equal to 12. So keep this in mind. I know I'm going a little fast, but I hope you're getting what I'm saying, because this is not very hard to understand, right? So let us move forward now. So after processing the fifth window, this will be our sixth window. And in this sixth window, we have to calculate the XOR from 6th to 9th index, right? So this is my next element and this is my previous element, right? So again, since we know that for the previous window, the XOR value was 7, 6, 1 and 8, right? So this 7, 6, 1 and 8 is present here. And in order to take the XOR of the current window only, we have to add the contribution of this 2 and remove the contribution of this 7, right? So taking a XOR with both of them, that is nums of 9 and this nums of 5, that is this 2 and 7. So this 7 and 7 will cancel out and this will only remain, that is 6182, that is this 6182. which is equal to 13. So I can say that the XOR of this current window is equal to 13, which we have to take a XOR with the previous result. So since previous result was equal to 12, so I will say 12 XOR 13, which is equal to nothing but 1. So that's why I can say that after processing the sixth window, our result is equal to 1, right? So let us move forward with the last second window. So this is our last second window, and in this, as you can see that we have to calculate the XOR from the 7th to the 10th index, right? So this is our next element, this is our previous element, which is both getting increased by 1 every time. Since the elements present in the XOR array before was 6182, which was written here, right? So we will again carry it forward. So 6182 will be present here, right? Because as of now our window is this, right? But we want to add the contribution of this 9, so that's why we are taking a XOR with this 9 here. And since we want to decrease the contribution of this 6, so that's why we are again taking a XOR with it. So that's why in this way the number of elements that will be present in my window here will be equal to 1829, because these 6 will cancel out each other. And if you calculate this, then this will be equal to 2, right? So the XOR of the current window is equal to 2, and now we have to take a XOR with the previous result. So since previous result was equal to 1, so I will say 1 XOR this current XOR, that is 1 XOR 2, which is equal to 3. So that means that after processing the 7th window, our final result is 3. And now we will go to the last window, right? So this is our last window, and as you can see that now our next element is pointing to the last index, and our previous element is pointing to the 7th index, right? So again, for the previous window, you know that the elements present in the window as of now is 1829, right? 1829. So the window is currently looking like this, right? So in order to increase the contribution of the 77 or add the contribution of the 77 to the current window, I will take a XOR with it, that is this XOR 77, and to remove the contribution of this one, I will again take a XOR with it, that is XOR 1. So in this way it will decrease like this, right? So that's why XOR 77 and XOR 1. So this 1 and 1 will cancel out. This is from the previous window and this is from the next window, that is current window. So after both of these have been cancelled, this will remain, that is 82977, that is this 82977, right? And if you calculate it, then it will be equal to 78. So it means that the XOR of this current window is equal to nothing but 78. And since the XOR of current window has been calculated, so it means that we have to take the XOR of this current XOR with the previous result. So the previous result was equal to 3, so I will say 3 XOR this 78. So this 3 XOR 78 is equal to 77. So that's why I can say that my final answer is nothing but this 77 only, and you just have to print this 77. So that's why this is my final answer. So I hope you got everything till now, and if I show you the code, then this is the code here. And first you have to take the inputs for n and k, then x, a, b, c. Then using the generator function, you have to generate the array in one based type. And then, as I have told you, that we will handle the first window separately by making a loop from 1 to k. So that's why I have run a loop from 1 to k, that is calculating the XOR manually. And once the XOR for this first window is calculated, I have simply XORed it with this result variable, which is answer here, right? So in this way our first window is handled. And for the remaining windows, since this loop had run from 1 to k, so it means that our next element will start from k plus 1 and will go till n, right? That is k plus 1 till n times. That is the total number of remaining windows is n minus k plus 1, that is this n minus this k plus 1. So our next element will be nothing but this nums of I, and our previous element will be nothing but this nums of I minus k. And we know that we have to XOR with both of them in order to get the XOR for the current window. And once the XOR of the current window is calculated, we have to take it XOR with the result variable and finally print that result. So this is the code, and this is the whole logic about this problem that I have told you. So if you got everything correctly, feel free to like this video and subscribe the channel if you're watching it for the first time, and share it with your friends who need to watch this series. So yeah, thank you so much for watching this video. Thank you.